In this video, we'll find the intersection of two quadratic graphs. Our question is, when do the graphs of the given two quadratic functions intersect? Use a two-column method and graph our results. We'll start by creating the x figures for our quadratic functions. On the left, we have pictured y equals x squared minus 6x plus 8, and on the right, we have pictured y equals minus x squared plus 4x. In our two-column approach, on the left, for our algebra pieces, we'll set our x figures equal to each other, and on the right, we set the function equations equal to each other. On the left, to cancel out the pieces on the right, we'll add 1 black x square and 4 opposite white x strips to each side. Symbolically, we'll add x squared minus 4x to each squared side. Now we'll simplify. For algebra pieces, we're left with 2 black x squared, 10 opposite x strips, and 8 black tiles. Symbolically, we have 2x squared minus 10x plus 8 equals 0. Now we'll divide each side into 2 equal groups for our algebra pieces, and symbolically we'll divide each side by 2, which simplifies to x squared minus 5x plus 4 equals 0. Now we'll create a factor rectangle. In this case, no zero pairs must be added. We had 5 opposite x strips, which can be arranged as 4 opposite x strips and 1 opposite x strip to surround the 1 by 4 array of black tiles. Symbolically, we'll split negative 5x into negative 4x minus x. Now for our algebra piecework, we'll measure the edge dimensions, which is x minus 1 across the top and x minus 4 down the side. In our symbolic work, we'll factor our equation. Here we've used factoring by grouping, and we factored out an x out of x squared minus 4x and a negative 1 out of negative x plus 4. So our factoring is quantity x minus 4 times quantity x minus 1, and this is all equal to 0. Now we'll set each edge set equal to 0 with our pieces, and we'll set those factors equal to 0 symbolically. Then we'll simplify. We'll add 1 or 4 to each side symbolically, and those algebra pieces will add 1 or 4 black edges to each side. We now know that x squared minus 6x plus 8 equals negative x squared plus 4x when x is 1 and when x is 4. We can use either function to find the y values of those intersection points. When we evaluate negative x squared plus 4x at 1, we get 3, and when we evaluate it at 4, we get 0. Our points of intersection are 1, 3, and 4, 0. To sketch each graph, we can plot those 2 points, 1, 3, and 4, 0, and the y-intercepts for each graph. So there's our pictured graph. Let's check. We should check that 1, 3, and 4, 0 are on both graphs. For y equals negative x squared plus 4x, we found 1, 3, and 4, 0. When we evaluate our other quadratic function, x squared minus 6x plus 8 at 1, we also get 3, that checks. And when we evaluate at 4, we also get 0, that checks. Our answer is y equals x squared minus 6x plus 8 and y equals negative x squared plus 4x intersect at 1, 3, and 4, 0. And our graph is included.